Good afternoon. In this training session, we're going to be talking about testing defrost control sensors. So in this training session, we will be discussing the test procedure for testing defrost control sensors. Now, some of the key points will be as follows. Checking 24-volt control voltage to the defrost control board, confirming DC voltage outputs on the control board, and using the sensor charts to confirm sensor readings. In addition, we'll be talking about the proper tools to measure ohms and the DC voltages on the sensor harness. The first thing that we'd like to talk a little bit about are the sensors themselves. The sensors are going to provide temperature information to the control board continuously. Now, let me stress this. Throughout the year, it doesn't matter if it's summer, it doesn't matter if it's winter or fall, the sensors are going to be reading outdoor air temperature as well as coil temperature. And during the heating season, what will happen when the outdoor air temperature gets to a certain point and the coil temperature gets to a certain point, it'll force a defrost on the control board. However, year round, it should be noted the sensors are active as long as the defrost control board has 24 volts to it. Now, it should be noted each one of these sensors is going to have a nominal calibration point of 10,000 ohms at 77 degrees Fahrenheit. So if the technician was to remove a sensor from the control board and subject that sensor to 77 degrees, let's say he had a glass of water that he knew was 77 degrees, and he put that sensor, and I always recommend taking some saran wrap so you don't soak the sensor in water, even though it probably wouldn't hurt it. It's not a good idea to just soak it in water. But if you were to take some saran wrap and put it on that sensor and put it in a glass of water that you knew was 77 degrees, and then take your ohm meter and set it up for ohms, your volt ohm meter, and set it up for ohms, and read the ohms on that sensor, it should be very, very close to 10,000 ohms at 77 degrees. So this is a really kind of neat way to calibrate to make sure that these sensors are in calibration. The technician can always do this as a calibration or a nominal calibration point by taking the sensor, remove it from the board, and ohm it out at 77 degrees. It should be around 10,000 ohms or very close to it. It should also be noticed that on these sensors, they're negative temperature coefficient type of sensor, which means the resistance goes up as the temperature goes down. Now, please note it is also recommended to use a temperature conductive compound between the sensor and the line it's attached to. This will just help ensure that the sensor itself is going to be reading the accurate temperature of the line if it happens to be a line sensor or a coil sensor. So let's take a look at that control board at this time. So this is a very typical defrost control board we're going to find on our Champion equipment. And we use this defrost control board a lot. Now, there are some different variations of it, but this is a very typical defrost control board. And by the way, the sensor checks that we're going to be talking about will apply to any of our product that has a outdoor and a coil sensor. And on some of our more advanced controls, you may even have a discharge line sensor. It doesn't matter. The principles all work the same. You can remove the sensor, you can ohm it out, you can plug it back on the board, you can look for DC voltages and so on, which we'll discuss in this training session. So the first thing we like to do is always make sure we have 24-volt AC between R and C terminals on the board itself. Now remember, team, the defrost control board has to have 24 volts to it all the time in order for it to function. And so on the thermostat itself, you're going to notice that you're going to have various inputs and outputs on the thermostat. You'll notice on the control board here, there's a Y and an O and a W and so on. But the very, very most important is probably to make sure when you're doing sensor checks to make sure you've got 24 volts to the board all the time. Now, this has to be around the year. It doesn't matter if it's summer, fall, or winter, or whatever the case may be. You have to have 24 volts on this board all the time between C and R. Now, if you don't have 24 volts on the board, repair it and fix it and figure out why you don't have 24 volts out there on this board all the time. So as long as you've got 24 volts on the board, the next step will be to find out if we have the DC output on the board that's necessary for the sensors. So once we've confirmed that we have 24 volt output, or excuse me, 24 volt input to the board between C and R, the next thing we want to do is we want to remove the coil and the ambient sensor from the board. Let me say that one more time. We're going to remove the sensors from the board, just unplug them from the board. where it says coil and ambient. And then we're going to take our voltmeter and we're going to be looking for 4 to 5 volt DC on the pins where the sensors actually plug onto the board. So an example would be if I'm checking the coil sensor pins, I'll go between the two little coil sensor pins with my volt ohm meter, DC voltage, and I'm looking for 4 to 5 volt DC on the two coil pins. Then I'll go over to the ambient pins. You'll notice that they're spaced differently. They have a different spacing on them. That way you can't mix up the coil and the ambient or the outdoor sensor, also called the ambient sensor, because the pin spacing is different. Same routine. If I go to the ambient sensor pins without the sensor plugged on, I should read 4 to 5 volt DC on the pins without the sensor plugged on. Now, team, this is very, very important. If I have 24 volts on the board between C and R, our previous check, and I do not have 4 to 5 volt DC on the coil pins and the ambient pins, then the board is bad. You don't have to go any further. You know that the board is not supporting the sensors because it doesn't have the DC output of 4 to 5 volt DC on the pins. However, on the other side of that coin, if you do have 24 volts on the board, 24 volt AC between C and R on the board, and you do have 4 to 5 volt DC on the sensor pins, and you do have 4 to 5 volt DC on the coil and ambient sensor pins, I should say, together and individually, then you know that the board is probably okay. Let me say it one more time. If you got 24 volts going to the board and you have 4 to 5 volt DC on the sensor pins, then the board is probably okay. And if you're having issues with the defrost control and you think it might be a sensor, it's probably going to be a sensor, because chances are that the sensor has gone bad and it's not a control board. So I know a lot of times a contractor, you know, they have the attitude, well, if I replace the sensors, I might as well replace the board, or if I replace the board, I might as well replace the sensors. But a lot of times we find out that the boards themselves there's nothing wrong with the boards on ones that have been returned for warranty. So we're always going to suspect the sensors before we suspect the board. So one more time, if we've got 24 volts on the board and we have 4 to 5 volt DC on our sensor pins without the sensors plugged on, chances are it's not the board. Okay, so let's dig in a little bit more. So let's take a look at the sensor resistance charts, and please follow along as we do some examples with the factory sensor charts as we take a look at resistance as well as voltage. Now remember, these values will always be in reference to a measured temperature. So the following tools that we're going to have to properly utilize the sensor charts and to properly check sensors are as follows. We're going to need a good high quality volt ohm meter with DC voltage measurement capability. In addition, I'm going to recommend that you have needlepoint meter probes as well. And the reason we want the needlepoint meter leads is once we pull the sensor off and we do some checks on it, we can plug it back onto the board, and our sensor charts will actually tell us the DC voltage with the sensor plugged back onto the board. But in order to get into the harness itself, with the sensor plugged back onto the board to kind of sneak in behind that sensor plug with it plugged into the board, needlepoint meter leads are extremely handy to get in there and actually read the DC voltage of the sensor with it plugged back onto the board. And you're also going to need a high quality electronic temperature probe, because there's going to be times you're going to be clamping on to a line. For instance, on the coil sensor, you're going to clamp on your electronic temperature probe, clamp on where that coil sensor is actually mounted onto the coil outside on the heat pump, and you're going to need to read the temperature of that refrigerant line where that sensor is clamped on. In addition, you're going to want to be able to make accurate readings of outdoor air temperature to measure and to accurately measure your ambient or your outdoor sensor. And finally, on some products, we do have a discharge line sensor as well, and you're going to need a good high quality temperature probe to where you can clamp on to that discharge line off the compressor where that sensor is actually located and read the temperature of that discharge line. So you get the idea. You have to have a good quality temperature probe if you're going to make all this work for you. So good tools are definitely recommended. So let's take a look at those charts at this time. So we'll notice on this particular chart, we're looking at the the ambient or the outdoor temperature sensor chart. And let's do a couple examples together. So let's say, for instance, we go to the chart and we measure our outdoor temperature. And let's say our outdoor temperature in this example is 10 degrees outdoor air temperature. Now, if you take a look at the chart very closely, you're going to notice that 10-degree temperature, we see that on the left-hand side of the chart, 10-degree temperature. If we remove that sensor from the board, you'll notice that in the resistance or the ohms column on the chart, it'll tell you what the ohms or the resistance of that sensor should be at 10 degrees outdoor air temperature on the ambient sensor. So in this example, if we know it's 10 degrees outside because we measured the outdoor air temperature, and we remove the sensor from the board, and we take an ohm meter and we ohm out that sensor as we remove it off the board, it should be 61,711 ohms. Or on a digital ohm meter, it'll read something like 61.7 K, 61.7 K ohms. And so depending on the type of meter you have, if you have an analog meter, it'll read, you'll have to look at the meter and extrapolate it 61,711. Or if it's a digital meter, a digital ohm meter, it may read 61.7 K. You get the idea. So basically, the resistance of that sensor, that outdoor ambient sensor at 10 degrees should be 61,700 or very, very close to it. Now watch this. If you take that sensor at 10-degree outdoor temperature and you plug it back onto the board, and you take your needlepoint meter leads and go in behind that sensor with it plugged onto the board in the harness itself, and you read the DC voltage on that sensor with it plugged back onto the board, it should read 2.63 volts DC. Let me say that one more time. If you plug the sensor back onto the board after you do your ohm check, and you plug it back on the board, and you take your needlepoint meter leads and get in there and kind of dig into the back of the harness, the sensor harness, and you can read the voltage of the sensor with it plugged back onto the board, it should be 2.63 volts DC at 10 degrees outside. Let's do another example. Let's say we're looking at, again, an ambient or outdoor temperature sensor, the one that just kind of hangs down below the control panel. This is the ambient or the outdoor sensor. Let's say it's 35 degrees outside. If I know it's 35 degrees outside because I measured my outdoor air temperature, and I remove the sensor from the board, and I take my ohm meter and I read the ohms or the resistance of that sensor at 35 degrees outside, it should read 29,986 ohms with it unplugged off the board. Now remember, team, this is within a few points of tolerance. So in other words, if it read 29,500, it's close enough. If it read 30,000 ohms, that's close enough. You get the idea. So it isn't, it's science. It just isn't rocket science, so to speak. So it needs to be very close to that reading. But if it's a little bit off, don't worry about it. An example would be, though, if your meter said OL, that means the sensor is open electrically. It's open electrically if it says OL. If it had 0 ohms, or if it had 15 ohms or some very, very low ohm number, that means that the sensor is shorted internally. And so normally sensors, when they fail, they just open. They just say OL on them, and they have no reading at all. But occasionally you'll find one that's shorted inside with a very, very low ohm rating. So just remember, at any given temperature, at any given known temperature, you can unplug the sensor from the board, and you can read the ohms by taking your ohm meter. And in this example, at 35 degrees outside, the ohms should be about 29,900 ohms with it unplugged off the board. Now hang on a second. If I take that sensor and plug it back onto the board at 35 degrees, and I take my voltmeter and I set my voltmeter to DC volts, and I take my needlepoint meter leads and I kind of dig into the back of that harness, I should read 1.74 volt DC with the sensor plugged back onto the board. Now, team, one other thing that we want to be very, very careful of is that we want to make sure that when we're doing any of these sensor readings, that we take a good accurate temperature. We have a good quality temperature probe. We take a good accurate temperature of the temperature that that sensor is subject to. So it goes without saying, please do not hold the sensor in your hand. Don't touch the sensor bulb itself. because the temperature of your hand will actually throw that sensor off. So be sure that you don't touch the sensor bulb itself or the sensing bulb itself, but just make sure that if you're going to handle the sensor, just make sure you unplug it at the plug, at the little harness that plugs off and onto the board itself. Let's do one more example, and then we'll go on to checking some other sensors as we take a look at how to do those and compared to the temperatures they're subject to as well. So on this final example, we notice that we have some more temperature columns on the ambient or outdoor sensor chart. And you'll notice in this example at 95-degree outdoor air temperature, at 95 degrees, if we unplug the sensor from the board, it should read about 6,500 ohms if we unplug it off the board and read the ohms. And if we plug it back onto the board and we take our DC voltmeter, we'll see that it should be about 0.52 volt DC with the sensor plugged back onto the board. Now, please remember, team, if we take those sensors off the board and we read the voltage on those sensor pins with nothing plugged onto them, they should be 4 to 5 volt DC without a sensor plugged on at all. Okay, let's take a look at that liquid line or that coil sensor. Now, that coil sensor is going to be clamped on a heat pump. It's going to be clamped on one of the outdoor coil passes outside on the heat pump on the outdoor coil. And let's say, for instance, I measure my outdoor coil temperature is 40 degrees. Well, you'll notice on these charts, they all work the same. As long as you've got the temperature, you're going to have a resistance column and you're going to have a voltage column. And so in this example, let's say we have a coil temperature of 40 degrees and we actually clamp on with our electronic temperature probe, and my actual coil temperature in this example is 40 degrees. Well, if I unplug that coil sensor from the board and read the ohms, it should be about 26,000 ohms and some change. If I plug that sensor back onto the board and dig in with my needlepoint meter leads back behind the harness, it should read 1.38 volt DC with the sensor plugged back on. And one final example with the liquid line sensor. Let's say we have a liquid line temperature or a coil temperature sensor, temperature of 85 degrees Fahrenheit. At 85 degrees Fahrenheit, if I unplug the sensor from the board, it should be about 8,250 ohms with the sensor unplugged off the board at 85 degrees. And if I plug it back onto the board and read that DC voltage at the back of that harness, it should be about 0.54 volt DC. Now remember, team, as long as the control board is able to support the sensors and you're reading the ohms on the sensor and if the DC voltage is very, very close, then you know the board is supporting that sensor. Anytime you take that sensor off the board, if you ohm it out at any given temperature, if it doesn't line up with this resistance or this ohm column on the sensor charts, then you know you have a bad sensor. And please remember, if you're having problems with your sensors, it's probably not the control board, it's probably the sensor that's bad. And again, the sensors, if they're open electrically, your meter will read OL. If it's shorted electrically, it'll be a very low ohm value, maybe 10, 15, maybe even 100 ohms. And if it's supposed to be, in our example there, 8,200 ohms, and it only reads, say, 100 or 150 ohms, then you know the sensor is partially shorted internally and it needs to be replaced. So one final example, let's say, for instance, we do have a product, maybe it's one of our HL19 products, our higher end product, and it has a discharge line sensor. It may have a discharge line sensor on it. Well, these charts, they still work the same, team. Basically, what you're going to do is you're going to measure the temperature of that discharge line. You're going to clamp on your good high quality temperature probe, and you're going to measure the temperature of that discharge line if it's so equipped. And let's say that discharge line is 165 degrees Fahrenheit. If I unplug the sensor from the board and I go over and I look at the resistance or the ohms column, I should read about 1,530, about 1,530 ohms with the sensor unplugged. But hang on a second, we can always do a sensor check with the sensor plugged back onto the board, as long as that board is reading 4 to 5 volt DC with nothing plugged on. If I plug that sensor back onto the board and I take my DC voltmeter and my needlepoint meter leads, in this example here at 165 degree discharge line temperature, and about 1500 ohms with it unplugged off the board. I plug it back onto the board. I should read about 2.38 volt DC with the sensor plugged back in. So team, that's how we do it. That's how we check sensors. When we want to, if we go up to a defrost control and we suspect that it's not working right, or the sensors aren't working, instead of just replacing everything, let's take a few minutes and get in there and check those sensors and check the DC voltage and make sure we have 24 volts AC up to between C and R on the defrost control, and then start digging in and checking those sensors and be proactive about our testing procedures. But at this time, we're going to thank you for viewing this presentation, and hopefully this will be helpful to you. This will be posted out on our YouTube training channel. It'll be called Testing Sensors, Testing Defrost Control Sensors, and today's date, which is going to be 06/09, it's the 9th of June, 06/09/2022. Thank you.